Okay, so this is the sum of n terms of a geometric series. This question was taken from paper 2 2020. It was question 15. This is question 14 on the trial exam. So the way to do this, if we write out the series, so we have sum of n terms. Now, first term is always a. Then we have AR, then AR squared, and so on and so on. And write a few more at the end. Now, if we're summing n terms, of course, the nth term is going to be AR to the power n subtract 1. Now, if you're not familiar with that, just consider which term you're in. So we've got term 1, term 2, term 3, etc. You'll notice that the power of r that you have, okay, so you can see here AR to the 1, we've got r to the 0 in term 1. The power of r that you have is always 1 less than the term that you're in. So when you get to the end, you're in the nth term. So you have n minus 1 orders of r, okay? Then the term before that, we have to subtract a power of r. So that's going to be AR to the power n subtract 2. I'm just going to put another one in as well. Let's just move those. In fact, I'm just going to get rid of that and try again. Okay, plus AR to the n subtract 3. Okay, this is the n minus 1th term, and that is the n minus 2th term, and so on and so on. Okay, so there's n terms there. Right. Now, the trick here is not to write it backwards as we do with the arithmetic series. What we do is we write the whole thing out again. Okay, so we have A plus AR plus AR. Now, I'm going to leave the powers off for a second. You'll see why in a moment. Then we have AR plus AR plus AR. Now, what we do is we multiply the whole thing by R. Now, this is going to increase the power of R by 1 each time. So the first term is now going to be AR. Then we have AR squared. Then we have AR cubed. And then when we get to the end, we have AR to the power n because we add 1 order of R. Then we have n subtract 1. And then we have n subtract 2. Okay. Now, this is the trick. We subtract row 2 from row 1 or vice versa. It doesn't matter. We're going to subtract the whole thing. So we subtract on the left-hand side of the equation. We subtract on the right-hand side of the equation. Now, on the left-hand side, we're going to get Sn subtract R Sn like that. And on the right-hand side, we see something really nice happening. So if you look at what will happen when we subtract, there's nothing to subtract from A. Well, there's the whole series. But if you notice the pairings, the AR and the AR will cancel because it's row 1 subtract row 2. AR squared and AR squared will cancel. AR cubed would obviously cancel with the AR cubed that's not written there. AR to the n minus 3 would cancel with the AR to the n minus 3 that's not written in, and so on and so on. Okay, the only terms that do not cancel are the first term in the first row and the final term in the second row. Everything else cancels out. Okay, so what we are left with is A, because that's in the top row, subtract AR to the n. Okay. So this is really neat. Now we can factor out the sum of n terms. So we have Sn multiplied by 1 minus r is equal to, on the right-hand side, factor out the a. So that's going to be 1 minus r to the n. And then we divide by 1 minus r, and hey presto, we have our formula. There we go. Now, in the sequences in series lesson, I did stipulate you do need to learn this as part of the course, and you can see it was a question 2 years ago on the paper. And for the next bit, for part B, it says, given also that S10 is 4 times S5. So the sum of the first 10 terms is 4 times greater than the sum of the first 5 terms, which makes sense, I suppose, if you're adding an extra 5 terms, aren't you? Okay, so it makes sense that that would be the case. But the fact that it's 4, that's arbitrary. Okay, it's just this particular situation. So let's think of the left-hand side and what happens when we sub in n equals 10. So we can see that if we have n s subscript 10, that means our n has to be 10, okay, in our formula. So let's do that. So we sub in n equals 10. So we're going to have a multiplied by 1 minus r to the power 10 over 1 subtract r. And then on the right-hand side, this is 4 lots of the same formula, but with 5 subbed in for n. So a and then 1 minus r to the power 5 over 1 minus r, 1 subtract r. Now, this looks pretty bad if you don't spot that, first of all, a is non-zero, as you can see in the question. R cannot equal 1. So the denominator can never be 0 on both sides. This isn't 0. And you have common factors on both sides. You have a over 1 minus r on both sides of the equation. They can just cancel out, okay? So what you're left with is this. You're going to be left with 1 subtract r to the power 10 equal to 4 lots of 1 subtract r to the 5. If we expand and simplify that, we get 4 subtract 4 r to the 5. Now, I'm running out of space. I'm just going to move up to the top of the page. This still doesn't look particularly nice, but if we collect everything on one side of the equal sign, so I'm going to take everything away from the left-hand side by adding r to the power 10 and subtracting 1. So I'm going to have r to the power 10 on the right-hand side, subtract 4r to the power 5. Okay, and then subtracting 1 from both sides, that's going to be plus 3. Okay, how does this help us? Well, notice that the power of that leading term is double the power of the second term. This is a quadratic in disguise, okay? And it factorizes. So, depends on how comfortable you are. You can make a substitution at this stage if you like. You could write something like x equals r to the 5, but you don't need to do that if you don't want to. You'll just have to notice that when you factorize it, you'll get r to the power 5, subtract 3, and then r to the power 5, subtract 1. Because when you multiply out r to the power 5 multiplied by r to the power 5, you add the indices, so that's r to the power 10, and we get all the right amounts of everything. So therefore, we have r to the power 5 would equal 3, or r to the power 5 would equal 1. Now, we are told that r cannot equal 1. If you take the 5th root of 1, you're going to get 1. So we can't have that. But we can take the 5th root of 3, and that's not going to be 1. So for the exact value of r, we take the 5th root of 3. It doesn't want the decimal answer, it just wants the exact answer, and that's exactly what it is.